talk about bytes and files. And let me get here's my Python environment. Okay, so if you have a number, let me just get rid of this stuff. All right. So if you have a number, you can set I equals to 1. And I wonder if I need to mute my Twitch. Hearing funny echoes and there. Nope, mine's mute. Okay, anyway, so I is 1, and you can print I, and you can see what type of data is in there, and it's an integer, okay? So if it's an integer, I can make another integer, j equals I plus 1. And that is going to be also an integer. So this makes sense. All right, but now I can make a byte object, and as I mentioned, the hard thing for me about Python 3 was getting over thinking of bytes and integers and characters as all being pretty much the same thing, because they aren't anymore. So if I set a equal to the byte string, or byte array, I think this is, 0, 1, there. And I have to have an equal sign there. Okay, so now if I print A and type of A, that is a bytes object. That's what the B means. The B followed by single or double quotes and either \x hexadecimal values or letters in there for ASCII values, you get a byte array. And you can't add to a byte array. B equals A plus 1. Okay. You can't concatenate int to bytes, which is what some of you were getting as you tried to do these challenges where you have to get a number from the server and add 1 to it. And so you have to move it around the variable types. So if you want to convert that byte to an integer, one way is to pick a particular byte out of that byte array. So this one picks your A was equal to a byte array with only one element containing 0, 1, and now I pick the 0th byte out of it, and now I have an integer. That's one way to turn it into an integer, pick a particular byte. Now I can make another integer that C is B plus 1, and now I can convert C back to a bytes object. So if I wanted to add 1 to a byte object, this is one way to get there, going through all the various stages. So I make a byte object that contains a class bytes and contains a 1, which is, by the way, not the encoding for an ASCII character 1, which would be 31 in hex. It's a hex value of 1. And then I make an integer out of it, add 1 to the integer, and now I turn it into bytes again with bytes. So now I have managed to go from the byte value of 1 to the byte value of 2 by going through a few conversions. And this, I think, is what I spend a lot of my time at Python doing, is moving things from string to byte array to integer and back and forth. All right. Anyway, so then let's talk about file input-output. I found a very nice way to do it, and learned it, I think, from Stack Exchange or something, but I was very happy to get it working. So let's get out of here and make a file. I'm going to see, let's see, I think I don't have much in this directory. Good. So I'm going to make a file called hello, and that's going to say hello. Okay, so that's all I've done. I make a plain text file to play with. And now I'm going to make this program, which is going to be read. By the way, this reminds me of something all important to tell you. Notice how I try to do a read operation here. If you name a local file equal to the name of a library, you will suffer. Then when you import the library, you'll be importing your local file. So don't use names that are used by libraries. I don't think read is actually a library name. I think it's all right, but I think I'll make it read1. It's just safer. That has confused some students. They made like a local file called requests.py, and then when they import the requests library, they're importing their own code, not the real code. No, I'll check the attendance later. It's good to remind me, though. Anyway, so, all right. So now this is how you open a file. You do with, then it will open the file with a file handle, and if you put a colon here, then it will indent the files, and it'll do all this indented stuff with the file open, and when it stops being indented, it'll automatically close the file. So that's kind of handy. So I reopen the file with this name, and I read it as read binary. So I'm going to read bytes. So now I read 1 byte, and if it's not an empty byte, then I print it and read the next. So this will read the whole file if it's named in file, and I actually named my file hello, so I'm just going to change this name here to match it, I guess. There, now it'll read hello and print every byte in the hello file. Unless I fouled it up, which is possible. So read. All right, and there it goes, reading all the bytes and finding the carriage return that the editor put at the end of it. So that's how you read a file byte by byte and put it in byte objects. And so now you got a few challenges. Here's a file you can download, and you want to find out how many bytes in that file are equal to 8. So and here's the one where you add two files, and we were talking about this one earlier, and I think I've still got the example set up here. Yeah, so here you have two files to add together like this. The first, they're both the same length. The first byte is 13, and the next one, the first byte is 41. So when you add that, you get 54 down here, and so on it goes. Let me see if I can fit these on the screen better. There we are. So 14 plus 54 is 68, and that's starting to spell out readable letters. So these are not readable or useful the way they are, but when you add them byte by byte, you will construct an ASCII string that will include the flag. And here's another one. You add these bytes together, you're going to get an image file that you can open in an image viewer with a ping file extension. So those are a few things to practice input-output and handling bytes.